Hello, and welcome to another Notional Pipe stream, where we stream about pipes, that are notional rather than concrete, I suppose. Um, as we sort of had discussed last time, I think the thing that we're going to move on to this time is going to be we're going to get right into doing the leg. This is for anyone joining for the first time. A series on doing componentized rigs, where we are building a rig system much like an auto rigger, but in a more flexible way using this concept of rig components. And one of the things that we are starting to do now is to build a more complex component. We had previously built a finger on stream, and I'd shown the arm, which is more complex than the finger, but we hadn't really dived into exactly how the arm works. And this time we're going to build a leg, which is actually the most complex component we have.
Yes.
But and will for sure take more than one session. But before we do that, I don't know. There's a couple of other things we can talk about.
Well, I should mention, first of all,
Mhm.
that we actually have begun the process of starting to integrate these modular components into Contour itself in Maya.
That's right, we have.
So what our plan is that the first thing we're going to release, we're going to do this in steps and basically release something that's useful but not fully featured first, and then continue to add to it and make it more fully featured as time goes on. But the first thing that we're going to add is a standard biped. And I think that will mark our 1.1 release of Contour, and it will give people the ability to just pull in a standard biped. And that should make it should cover a lot of the ground where, Contour is not an auto rigger, right? It's a set of primitives for rigging, and they're very, very useful. But I think there are a lot of people who would like it if it did something a lot more like an auto rigger. And while this isn't exactly auto rigging, it will serve the same purpose. You'll be able to pull in a biped, resize it, do a small amount of weight painting, because Contour does not require nearly as much weight painting as traditional rigs, and have something that's good to go.
Yeah, and I mean, sorry, go ahead.
Go on. No, go right ahead.
I was going to say, and that is really something, and we've heard this from people a lot, right? It's sort of missing right now. I mean, we built Contour in part, like, unlike the setup machine, right? Unlike something that's purely an auto rigger, we wanted to give these much better primitives for rigging, like much better than what already exists. But of course, a lot of the people who need rigs, aren't riggers, right? And even though this makes rigging a lot easier, you still have to do some rigging, right? So, I mean, you would anyway, right? You're not going to completely avoid it. But
sure. We'll never be able to completely avoid it. But I do think that, I think that a lot of where I think our attention is going to turn going forward, because, Contour, the algorithms are pretty solid. They pretty much work. Modulo a couple of bugs in Maya that we can't do too much about. And, but that are not showstoppers, that they're good workarounds for. But I think that kind of the next step with Contour is to make it more of a complete solution that does more for you. Right. And it'll always have this thing where you have access to these primitives. And if you want to do some sophisticated rigging that's like very specific to what you want to do, those tools are there for you. But it would be nice if Contour were more of a sort of, like point and go kind of thing for fairly standard problems. Right.
Right.
And, I mean, one thing we've actually started to talk a little bit about is there something that we can do for face rigging, right? Because Contour is useful for certain aspects of rigging faces, but it's not a face rigging solution at this point.
Right. And it actually is an interesting problem. I mean, I've talked before on the stream about the fact that facial rigging, sort of in the general case, right, as opposed to like something really, really specific you might do for a specific project, is just a really, really wide open problem. And so there are aspects of that are difficult, but I think I see, in part because of some other work that I've been doing somewhat recently, maybe a way to do it. We had done the face machine, quite a long time ago at Ansevin Studio, and the face machine worked very well for some people. It did have some issues too. We wouldn't want to approach it in exactly the same way. But it would be a lot of work to put together. So we're not making any promises or making any sort of, like, don't take this as like a promise of something we're going to add to rig tools in the future, but it's definitely something we're thinking about. And there may be a way to do it.
Yeah, the biped is pretty much a promise. That's going to be out.
Yeah.
I think we can go so far as to say that I expect it to be out sometime. We don't like to put exact dates on things because sometimes difficulties come up. It's hard to know. But I think there's a good chance that it will be out in the next, 6 weeks or so.
Yeah.
But if not, it'll be a little bit longer than that. It won't be a tremendously long time.
Right. And here's another thing that's worth mentioning. In the Game Awards recently, they finally announced Judas, a project that I was actually working on a few years ago, but, couldn't really talk about because it was super, super secret. And I still can't really talk about much about it because it's still mostly super secret, and I am definitely under, NDAs that prevent me from saying much about it. But I am pleased that it, it exists, and I can now sort of talk about its existence. It is the, sort of the spiritual successor, I guess, to the BioShock games. It was done by Ken Levine's studio Ghost Story Games, which is sort of the, sort of what I guess what Irrational sort of became. And one of the things I was doing a few years ago was just doing rigs for them, right? They had some internal rigging stuff that was left over from BioShock Infinite, but mostly they didn't really have a rigging team anymore because they were a much smaller crew. And so, I didn't really see the project out. I mean, I worked there for about a year and ended up handing it off to some other people. But it was an interesting experience. It's the first experience I've had really working as part of a team doing game dev. And informed some of the ways that I think now about, like, how would you make rigs that are intended to go into a game engine. So anyway, I thought I would mention that. It's kind of cool. It's cool that I can finally acknowledge that this thing exists.
Okay, well, so I think, there has been a little bit of time for people to join, et cetera, et cetera. Perhaps it is time to get to the leg rigging. But yeah, that's really exciting. Congratulations about Judas.
Yeah, well, I mean, honestly, I didn't do anything terribly important on it other than make a bunch of rigs, so I don't know that, particular congratulations to me are warranted, but, I'm pleased to see it out there.
Well, I mean, it's always nice to see work that you've done actually get out there and, start to actually exist in the world.
Yep. So, to start off with, here is one thing I am going to do in this leg rigging, thing that, I resisted in the first, the sort of the first section of this componentized rigging, unit or series. And that is, I am going to use a lot of Python. And the reason why I'm going to do that is that otherwise this is just, really painful. Like, we sort of had, like, in earlier streams, I showed going through and creating these things by hand, creating all of the nodes necessary to do them by hand. Once you end up doing a lot of that, it becomes sort of painful, right? And so what I had actually done prior to that was to put together a few functions that sort of help me assemble these things. And I want to go through those real quickly because we are going to be making use of them. Just as I made use of them when I first sort of assembled the ARM, which I didn't do on stream. So, and these are basically some utilities, that I've honestly had floating around for a while. Like, they're just pieces of stuff that I wrote over the years that I've, sort of carried around from project to project to some extent. And, they're actually quite simple in a lot of ways, but they let you do some things that just make this a lot easier. For instance, you remember how, like, 10,000 times probably I made a mult matrix and plugged two things into it? Now there's a function that I can just call to do that. Making a decomposed matrix. Driving some node with the output of a decomposed matrix, right? These are all things you just have to do constantly, and doing them by hand every time just gets incredibly repetitive, and I sort of hate that sort of thing. And the other thing about this is that they're composable. And you'll immediately, shortly see me using them in this composable way, but for instance, you can pass the output of matrix in space, which, I sort of wonder if that actually implies that they are, I think this was a joke you made, Tagore, actually, when we were looking at this, that this is not unlike Pigs in Space, which is a deep cut Muppets reference. I don't know.
Yeah, well, that's just when I saw Matrix in Space.
Yeah, exactly.
I don't know. I have a tendency to free associate, perhaps a little more than is entirely healthy, but.
And then you can pass the result of Matrix in Space, into the Matrix input of Drive with Matrix. Right, I mean, the argument that you're passing to Drive with Matrix. So in a lot of cases, you'd just be like, sticking Matrix in Space in here, which we will probably be doing imminently, right? In order to drive something off a matrix with a particular set of inputs. Honestly, the naming here isn't great. Probably I should have called this matrix output and space output, because what these are basically about is Well, no, input actually does make sense, right? Because these are inputs. They are coming from off the input transform, where we have, in the case of the arm, and I have the arm in this file sort of for reference, because the leg and the arm are going to share certainly some characteristics in common. I have these input nodes. Anyone who's followed, the earlier, streams about this subject will certainly recognize this, including a whole bunch of matrix inputs that come into the component. And so all of the stuff that I did manually in earlier streams, grabbing, grabbing these matrix inputs, putting them through mult matrix and decompose matrix and etc. nodes, all that stuff is something that I'd much rather do with a script. There are, however, and we will also get to those probably this session, maybe not, maybe that'll be next session, we'll see, a few things that are a bit more complicated. This pole vector transformation, for instance, comes from a very similar sort of approach. But unlike, matrix and space and decompose matrix input and all of this stuff, where they're just sort of like little, tiny little functions that you're supposed to sort of stick together to do whatever you need, pole vector transformation is much more complicated, because what it has to do is actually to figure out where a pole vector ought to go. So the network that gets created by that function makes the pole vector do this, right? It makes the pole vector figure out what position it ought to take relative to, basically by looking at the 3 points of these inputs, which is something that isn't actually very difficult to do in terms of math. However, because we're making it in Maya, and we need this to happen not once when the rig gets built, but anytime you move this thing around, so it must be something that evaluates through the graph, and the way that we're doing this is to use these math nodes. The actual thing that makes that happen ends up being a bit complicated, simply because it has to build the nodes to do it. This is one of the reasons why, if you are actually making a auto-rigger in sort of a conventional one, it often ends up being much more complicated than if you were to express what the rig is intended to do through code. Because you have to account for the fact that not only do you need to figure out what the rig's behavior ought to actually be, but you need to also figure out how to represent it with a whole bunch of Maya nodes of various kinds. And this actually tends to end up making things considerably more complicated. Anyway, I will, when we get to this point, probably go through this a bit more, a bit more in detail and sort of explain what it's doing. I don't really want to do it by hand, because that would be really obnoxious, right? I already have a piece of code that does it, but I will at least go through and try to explain why this functions the way it does and what exactly it's doing. And similarly, I have something else for making space switches that's a bit more complicated. But we don't really have to deal with that right now. What we are going to start with is, in terms of figuring out how are our guides going to function, right? I'm going to use some ad hoc Python here too. I do apologize. I just can't handle doing it all by hand anymore. And we've done that a few times, so I think I've maybe sort of gotten the point across about what that is and how it functions. How you would do it by hand if you didn't have any other option. And I'm going to start, actually, just by using the contour join tool to put down something leg-like. Just as a starting point. I'm going to hide the radius, because that really does not matter at this time. And the proportions are all wacky, but that also doesn't really matter, because we're going to, make them fully adjustable with our guides, right? So the first thing that I think we will do is actually to create all of the elements that the rig actually needs, and then figure out how to drive them with guides. Is that actually the most efficient way to do it? Maybe not entirely, because we do, of course, have a reverse foot rig. That's one of the reasons why the foot's actually a bit more complicated than the arm, right? That's actually the specific reason why it is more complicated than the arm. The arm doesn't have any sort of concept of a reverse foot anything. There's no need for such a thing on an arm, right? Because we do need to do that for the foot. That's what makes it a bit more complicated. Although, it is going to be considerably less complicated than it would be if we were attempting to do this sort of in a more conventional way, not using contour. And a big part of the reason for that is that and I sort of alluded to this earlier, but a whole bunch of the stuff that we get for free from contour IK chains, for instance, like the ability to do auto stretch and smooth stretch in a conventional system, you could make this componentized, but you probably need to explicitly build all that stuff in as subcomponents. And that would be a lot more time consuming, right? Contour makes that considerably less complex. So to begin with, in that case, and sorry that I'm sort of like thinking about it right now instead of figuring it out beforehand, but sometimes you just, get it into a particular state and then you decide how, where is the right point to go into the problem, right? I think that I will actually start in that case by making the guides, which are going to be pretty simple. In fact, yeah, I can just do this. I'm gonna make some locators. Here are the guides. We are going to name them, again, referring to our arm to make sure that we do things, in a consistent fashion. I'm going to call this hip guide. I did not type that correctly. And as a starting point, let's just fit them to the joints I already have in here, right? Now, I'm actually going to do things in quite a bit of a different order than I did them with the finger. In the finger, I first started, I first created these guides without the guides having any relationship to each other, except that I had parented them in a hierarchy. And I then proceeded to, after I had hooked everything up properly, which took approximately 10,000 years because I didn't have any functions to help me with it, I set it up so that they were aiming at each other with constraints and stuff. In this case, I'm going to start it off that way because I know I need to do it, and I know that the legs, if they ever get out of alignment, the legs are going to do some weird stuff, and I might as well just, I know it's something I need to do, I might as well just do it right now. So that is going to be the next thing. 1 second. I'm going to save this file because I haven't even saved it yet. So the one thing here is that our toe guide, which arguably should be called like how did I do it with because the hand has like a hand overshoot. Would this be a toe overshoot? I think maybe it is, because the toe itself, like this end point, is not really doesn't really become a control specifically. It becomes it's essentially a way of saying like, well, we need overshoot into the toe area in order to get good deformation at the ball of the foot. So in this case, we simply parent it, and that's how we do it. And because of the way we want this to work, did I do this with the hand? I'm pretty sure I did. Yeah, I locked everything except translate X. We're going to say this thing, everything else is locked. We don't do anything else but translate X. And the ball of the foot is also sort of freely, we don't really need to do anything else to the ball in order to make it orient itself properly. Its placement in world, or I shouldn't even say in world, because we are going to probably parent it to like an overall control we can use to move all the guides around, is all that it actually needs. This one, however, does in fact, the ankle control, does in fact need to aim at the ball in order to maintain the idea that you have a chain here of the guides, and they're maintaining tangency with each other, which, and we sort of talked about this maybe a few sessions ago, but I think it's worth mentioning that that is an important assumption of this componentized system. Actually, that's not actually really true. The componentized system itself doesn't care. But these specific rigs that are using this componentized system, these specific components, do assume that their inputs are aligned with each other. And I have some questions about whether I think that's really the best thing, and maybe I will investigate for approaching things in a different way at some point, but for now, that's the decision that I've made. So we're going to do an aim. We are going to say, in this case, we're going to use the none world up type. I think I had some discussion of that at another time about like why none, like what does none mean? Actually, that seems like perhaps it isn't the right thing. Yes, because let me make sure I get this right before I go any further. As you can see, this has z pointing out of the basically being like the forward vector of the knee. And what does it look like? What did I decide to do? It's the opposite way for the elbow. That's probably not the right thing, is it? Right? Ideally, we kind of want them to be the same. I think it's better if it's consistent for arms and legs. We kind of want them to be the same thing. So we are actually going to flip this all around. And the simplest way to just flip it, I mean, we could go back into bone mode and like rotate these things around or anything we wanted to, but in this particular case, I think the easiest way to do it is just going to be to, do this, let's see, do it kind of manually. Let's see, next joint orient will now need to be negative. Now we have it pointing backwards from the bend, which I believe is the same thing that it is doing. Yeah, that is the same thing that it is doing for the elbow. And you could argue that it doesn't really matter. And in some contexts it doesn't, but I prefer things to be consistent. It doesn't really matter. You could also use Y as that axis. I mean, it probably has implications for rotate order, but it's not, I mean, you can do either way. But I prefer it to be consistent between them, and I have not always actually done so. So I'm trying to turn over a new leaf now. All right, let's just reorient these since now their orients are different. Now, we're still likely to, that was just something I noticed along the way, we're still likely to encounter an issue here. So now our aim vector is pointing down X, and we know that's correct, right? Because this is the direction that X is pointing. Z is pointing back here, though. This may not actually have the result. In fact, I'm quite certain it won't have the result that we want. What the heck did I just do there? I did the wrong one. That's what I did. Yeah, it flipped it around the other way. And in fact, it flipped it into a pretty weird orientation. I'm almost tempted to be like, exercise for the class. Why did it flip around to a weird orientation? But that's not very nice. I will explain why it did. So the world what happens when you do an aim with the world up type being none is that it basically does a rotate onto, which is a highly beneficial thing to be able to do. Right? Because what you're doing instead, you don't have an up vector in that case, is that you've got your axis, right? It's pointing down like this, and you've got some point that it's aiming, say, X at. Pretend my pointer finger is X. And instead of saying, well, I've got a vector from my thing to the thing I'm pointing at, and I have some up vector, and I'm going to make the orientation out of those things, so that the orientation is fully determined by those two vectors. I mean, that's how a normal sort of aim works. It's instead going to say, I'm going to take the orientation I have. I'm going to see what the difference is between the X vector and the vector between, my transform's location and whatever I'm aiming at. There's an angle that is the difference between those things, and I'm going to apply that to my transformation. It's a highly useful thing because it allows you, for instance, I mean, this is a great way if you're doing conventional twist and you're not using contour, which just handles it for you. It is a great way of being able to extract twist cleanly in a way that doesn't flip at 90 degrees. This is like a perennial issue that riggers had for a long time before we figured out that actually quaternions kind of, and what I'm talking about there is so usually implemented with quaternions, kind of make that problem go away. So in this case, the problem is this thing's in world space, right? So its default, no orientations or anything position is that x is pointing like over here. It's pointing out to the side because that's, if we look down at our xyz's here, that's world space location. Z is forward, right? So if you say aim x all the way over here, that's from this location, it's going to try to do that, and it's actually going to get something that's kind of weirdly in between. For the uses that we want to put this to, that's actually beneficial, right? That is a useful property. However, in this case, because if you're for instance aiming, an elbow at a hand and you want to use that to extract twist, then having it smoothly go over to a different orientation and like sort of use all the values in between instead of flipping at 90 degrees is highly desirable. It's a very good quality. In this case, it's extremely not a very good quality because we want these things to sort of like stay aligned in a nice way. And I think what I'm going to do with that, let me just think about this for a second. Like what do I want to do with this? Because one answer would be to actually get an up vector by using this guide up here, which you absolutely could do. Use that as the up vector, and then these 3 points define what that thing is. But is that really what we want to have happen with our rig when you scoot the ankle back and forth? Possibly not, because that will mean that it will actually take on an angle if these two things are not aligned. We kind of want it to just be like straight down the thing. So what I'm actually going to do here, and I may decide to change this later, maybe this isn't the approach that I'll take, is that I'm actually going to put specifically this ankle guide underneath a null that is oriented the way I want it to be. So that gives its initial orientation. Right, so I'm going to give it -90. And let's see, what was the actual orientation of what's this? So that's x pointing down. So then we want right, I'm going to fix that in a second. So this should give us something like x pointing forward, z pointing down. X pointing forward, z pointing down. That should work. Put this one back at this joint's location. And what we should get now is a nice clean value. A nice clean rotation where actually it's only giving us rotate y. And here's the important bit. If we scoot this one over here, it's not canting over very much. I mean, it is a little bit, right? And if you move it like way down, like over here somewhere, I mean, you'll start to see more rotation sort of on the x-axis, but it's not very much. And so that will give us this very nice stable aim, assuming that you don't decide to do something like aim it completely backwards, which this will not handle particularly well. And I may want to revisit this and, come up with a better way of handling that. In cases where I've done this before, I've actually just made the assumption that you're not going to do that, because when you have an internal system that you're going to use to make rigs, you're allowed to kind of make some assumptions about it because you know the kinds of characters you're going to make. When you're going to throw it out to the world, you have less opportunity to do that, right? So I may revisit this, but for the moment, I'm just going to call this ankle guide, ankle orienter maybe, or ankle guide orienter because it orients a guide. And I think fine. That'll be fine for now. We can change it if we want to later. All right. Now this, on the other hand, the knee, much simpler, right? Because what we need to do in the knee's case is we actually have a very clear idea of exactly how to fully determine its orientation to keep everything sort of clean and aligned. Because we have 3 points, and all 3 points make a plane, always, right? And there's actually a very simple way, just using a couple of aim constraints, and to make this all And I mean, it's already been done for the arm. So here's what like a finished version of that looks like. Note that as I'm moving this around, it is internally figuring out the rotate plane, basically the same concept as rotate plane IK, which I actually discovered recently when I was working on a feature for Contour called, what am I saying? A feature for the ephemeral system called reproportion. And I actually wrote a function that did basically exactly this, and discovered that I accidentally written an IK handle, because they're actually basically the same thing. And basically the idea here for rotate plane IK, I mean, there's other kinds of IK, so I probably shouldn't, assume that all IK is rotate plane. But for rotate plane IK with 2 bones, which is probably the most common kind you see, it's basically exactly this concept. Any 3 points gives you a plane. And in this case, it's really for IK, it's actually the pole vector, right? It's like, 0.1, 0.1, 0.2, 0.3. That gives you a plane that you can then figure out your IK in basically in 2D. So this is basically the same concept, just it's being used for a different purpose. And the way we can do that, actually, before I do any of that, I'm going to make these a little bigger because they're hard to select. So in order to know how to orient this guide, we have to aim it at this guide, but because we want Z to point backwards, right? We need its up vector to be this one, right? So it's actually pretty straightforward. We're going to say it's going to point X. It's going to be Z is going to be the up vector, and the world up type will be object up, and the object we will be using is ankle guide. I don't know why it uses the thing where you actually type in the name. Like Maya has like 10 different ways of indicating things to its UI, and they're all different, and it's a little unfortunate, but that is how it works. Let me just do that again, because I want to verify something. Because what this should do, if I've done this properly, is that it should not change the orientation of this much at all. Because these are all in a line from the front, or they should be, right? So in these 2 cases, their x-axis is 0, and in this one, because it's in a rotated space, it's actually the y-axis that's 0. But same idea, or it's supposed to be anyway. So I'm going to aim this at this, and the values did change a little. Oh, I see what happened. Haha, yes, so here's the reason why those values change. It's actually the same thing, but it's the other way around, because we're using, these are Euler angles, right? And Euler angles, can never know anything about, I mean, they're always, you never actually know when looking at the actual orientation, trying to figure it out in some other context using quaternions or matrices or anything else. You never actually know for sure what set of rotations are going to be used to make it up, because there's a whole bunch of rotations that could represent, a whole bunch of values that could represent that rotation. This is one of the reasons why personally, I hate Euler angles so much. They're so evil. It's unbelievable how bad they are and how damaging they are to the practice of rigging, right? And to the practice of animation, although it's at least understandable that animators want to deal with them, right? It's not understandable that we ever use them internally in rigging. So this should work, because if I move this over here, note that this is rotating such that its x-axis is still pointing this way. It's the axis pointing to the side. Oh, that doesn't seem quite right. That is not what it should be doing. Oh, no, that is what it should be doing. Ha! Sorry. That is actually completely correct. And here's why it's completely correct. Because, previously when we have this back, in the middle, right? This one's x-axis is pointing straight back. It's the plane made by these 3 points. If I do, in fact, move this out to the side here, though, I've almost changed that at 90 degrees, right? That plane is going to be about 90 degrees where it was. So you can see that it's actually doing the right thing. Like, z-axis is pointing out in this direction. It's the plane formed by those 3 points. Now I just need to do the same thing for this this one right here, which is actually the reverse. So in this case, it's actually the same thing. This one is the one that gets used as the up vector. This gets aimed at this. I believe it's actually the same exact values. We just change which thing is the up vector. And again, we get an orientation that is exactly what we expected it to be. And from now on, no matter where I move this, because it's in world space, this isn't evident, right? You can't look at the rotate values and understand that this is true. But it is. that if you were to put these both in the orientation that they're currently at in a space that was basically like the space of this plane, only one axis would be rotated. Right? This now means that effectively the rotation of these things in a sense is 2D, like in that plane. Which is like a really actually important concept for rigging. For IK, for like, you know, being able to do things that sort of maintain a good, I mean, largely it's an important concept for IK, actually, because part of the reason why we need them to be planar like that. Isai Calderon, I apologize if I mispronounced your name, says, can you enable the display local axis attribute on the hip guide? It would help visualize what you're doing. Yeah, that's a really good idea, actually. That would actually make it a little clearer. So note that if you look at the z-axis is probably when it's going to be the most clear, right? I move this thing all around, and if you were, and you can think that there's this very clear plane being made by them, and those z-axes are always on the plane. Like, you can always look at it from an angle where they line up. And the specific reason for that actually is, I mean, there's multiple reasons to do it, but IK is a big one, because just like the arm, legs are going to have IK, right? You know, that's a thing that pretty much all legs have. And therefore, if you want to be able to do this, but have your pole vector end up in the right place for the default position, the default orientation of all of your stuff to work with rotate plane IK, then this is how you want all of your inputs to be oriented. And that's actually something, unfortunately, that I see as being a huge issue with the way that a lot of, if you're doing stuff from scratch and you're, you know, sort of a little inexperienced, like, people make that mistake all the time of drawing bones, like conventional Maya bones. Interestingly, Contour, we actually accounted for this in the IK handle. It'll kind of like fix it for you with an offset. But if you do standard Maya IK handles, it will probably flip out real bad, actually. At some point, if you don't have things lined up nicely. And it's not very obvious when you don't, actually. You kind of have to know that that's important. And one of the important things I think about auto riggers, you know, back in the day, right? Back when auto riggers were actually kind of a new thing, instead of being like kind of an old thing now, right? Like something that's old and kind of, you know, like probably we ought to abandon, right? You know, back when it was new in the early 2000s, one of the good things about an auto rigger is that it could actually enforce that and prevent you from screwing it up. And it was so easy to mess it up. I mean, it still is, right? You know. So those are all, I think, pretty important concepts that get used all over the place in rigging contexts. Let's see. So now we've got those guides. They're sort of oriented in an appropriate way. Let's see. And I should say, you know, I am now, you know, again, as I often do, like, I'm mixing up stuff that's maybe, you know, basic enough to be pretty comprehensible to someone who's kind of new at rigging, with some concepts that are probably pretty foreign to, you know, anyone who hasn't done it for a while, because, I mean, they're often not what you learn in, like, basic rigging classes or something. So, if anything is unclear or just, like, completely off the wall, like, please ask in the comments. I'm very happy for this to be, like, a, you know, a give and take, and like, answer questions, and not necessarily just, like, declaim stuff at you. So, right, obviously, now, of course, I've got these guides. I haven't hooked them up to anything. So I think that's probably the next thing. I'm going to make a inputs node, just like the ARM has. Probably going to put that, yeah, I mean, I'll start making the structure. One thing I will just note, this is a bit of an aside, but it's something that I think is kind of important too, about like what I think of as being kind of good rigging practice. I am naming these things fairly specific things, but in my opinion, names of things, as in the actual name that the node has, is ideally not used to refer to the node when you're actually doing code. Sometimes it's just, that's just often how Maya works and you sort of go with it. But ideally, it's not. And so one of the things that is often true that is important, for instance, is to tag things And I don't think these things have tags automatically right now, if I look at like the ARM component. But some things do. Like we have this data node now that has some tags that have data like what the standard ARM is. And, you know, in a lot of cases, we will go through either on import or, like putting it right in the component and explicitly tag things so that we can tell what they are regardless of what they're named. So I want to note that like the fact that I'm naming this thing component to match what the ARM, the equivalent node in the ARM is for my convenience as a person to understand what's going on, not because it's going to matter for how we do the code that puts these things together in the end.
Yeah, I mean, and I'd like to say this is something that, as we've worked with Maya over the course of quite a few years and quite a few products now, that we have found more and more and more important. It's like tag things more rather than less. Put as many tags on, as many ways of sort of sorting nodes into conceptual categories as you possibly can. And that's part of what we were working on. It's part of what we were working on this weekend actually was setting up all of these tags. Unimportant stuff, but you want more tagging rather than less. And it's a lesson we've learned the hard way many times.
Isai Calderon says, I like message adders for that. Yeah, message adders are also a good way of doing it. I think we've come to prefer tags because they can carry sort of, in a sense, more data, right? So, for instance, one of the things we put in tags a lot are UUIDs. And message adders are fairly specific in a sense. Like you can go from a node and be like, oh, what is this node? What thing belongs to this node, right? You can have a message adder that tells you the necessary stuff for that very easily, and that is often a good idea, absolutely. But I think that we
use them pretty extensively. I think on like TSMG and TSM3.
That's right. Yep.
To specify relationships between.
Yes, things. Exactly. When you want to specify a relationship between two things, message adders are great. When you want to just be like, get me all of the things that exist in the scene of like type Y, then message adders are a lot less effective. So I think they both have their place for sure. I mean, you can write once you've tagged stuff, you can write a Python one-liner that gets you everything in the scene of a particular kind, assuming you don't care that it's probably kind of slow, right? But I mean, it actually might not even be that slow if you're not using PyMel. I just use PyMel all the time. I'm sorry. I know people don't like PyMel. They've got good reasons, but it is.
Yeah, you know what? Even using commands and even using OM2, querying the Maya scene for data about what's in the scene,
it's still slow.
We've never found a fast way to do it. I don't think there is one.
Yeah, well, let me put it this way. It's true. That's also really slow. But I think that doing it when you're using PyMel is often like even an order of magnitude slower.
Sure, but in the ephemeral system, like we need that stuff to be fast. We tried commands; it was still very much too slow. So we wind up keeping we cache a whole bunch of data.
That's right. We have to cache all the M objects,
and then we have a whole bunch of callbacks so that when things change about the scene, we have to update them because we need to query that kind of stuff very quickly. You just can't do it in Maya.
Yeah, it's really unfortunate. I don't really understand why that is the case, but it seems to be the case. Seems like that shouldn't be slow, but it is. Let's see. So where were we? Yeah, we need to make some inputs. Let's look at, again, what do the inputs look like? How have I sort of set these? How have I named these? Well, this seems pretty straightforward, right? I just need to do something similar. And once again, there is no way to do this through the UI. You can't make matrix attributes through the UI. So even if we weren't going to go ahead and use some Python this time, which we are, we would have to do this from the command line. There are no other choices, right? So actually, I'm going to introduce something here, which is that I have abbreviations that I use when I'm doing ad hoc Python for getting selections and stuff that I kind of want to use here because they're convenient. But I want to explain what I'm doing first because otherwise it's going to be real confusing, right? So one of the most common things to use is pa.selected. And I should note here, I've mentioned this before, but maybe people didn't remember. The most common thing to use for PyMel is PM, like that to be what you call when you import pymel.core or whatever. I actually use PA all the time because we started doing that at Ansevit Studio at some point, and it got so ingrained that I just reflexively type it now. But PM is a more common thing.
It's from pymel.all, which we used
That's
to
right.
import. And then we discovered that importing pymel.all can cause some real problems and that everything you need is in pymel.core. So we started importing pymel.core, but we just kept calling it PA.
We just kept calling it PA. And so, like, if I'm doing that and you're like, what the hell is that? It's actually PM. It's pymel.core. Anyway, yeah, so, like, pa.selected gets user selection, right? That just printed me out here like, oh, I've got a transform called inputs. I have aliased that to S, because you're just constantly getting the selection if you're doing ad hoc Python. So if I do S, like open parens, close parens, same thing. Now if I do S1, now I get the first item in the selection instead of having to index into it every single time. If I do S2, it's going to explode because there's no second item in the selection. Oh wait, no, you can't do that. It's out of range, right? So, like, don't use that in actual code because it's it's probably more of an abbreviation than is warranted, right? Like, actually, abbreviations are bad, like, sometimes anyway. And number two, like, it's not like that was a useful error or anything. That's completely confusing. So I wouldn't write actual code that uses this. But if I'm doing ad hoc Python things, it's super, super nice to just be able to be like, oh, S1. That's I have one item selected. That will get it, right? And I'm going to do, like, add adder. And I'm going to call this, like, what's an input that we need here? Hip. And I'm going to say that its data type is going to be matrix. And there's a whole thing here with data type and attribute type, but we're not going to go into it right now. Oh, and it's going to also complain because I probably typed it wrong. There we go. There's a hip. All right, again, I'm using some ad hoc Python, so I'm going to go ahead and do something that, wasn't doing before. I'm going to say for thing, it's one line, I don't even care what I call the variable, in, like, what are the other ones that I want? Knee, ankle, ball, what did I call it? Toe, what did I call this? Toe overshoot? Yeah. That is why I like using the command line. Let's see, to overshoot. What else do we need? Well, we're going to need all the same things that the ARM has in terms of an anchor and some space inputs, but we don't actually have to care about that right at this particular moment. So let's see. Here's some inputs. We need to drive some things from some inputs. Now it's time to use some actual code. Some of the code that I had written. Let's see. Let me just make sure I have this right. So normally, how am I going to arrange this? Because, like, I put this on my other monitor, right? But you can't see that. I think maybe that's okay. If it ever becomes important, because I just need to see what the functions are, If it ever becomes really important for me to show this, I will show it. And I kind of talked at the beginning about what this was, but for people just coming into the stream, these are a bunch of functions that I wrote at cribbed from various projects I've done at various times that are basically like, they're very simple. They're like, hook up two things. And in earlier streams, I was doing all of this manually, and I would create myself some mult matrix nodes and some decomposed matrix nodes and hook them all up manually. And, like, it was killing me, right? Like, it's so slow to do it that way. So I am going to make use of some of this stuff. Hopefully, because in earlier streams, I have, in fact, used, shown how to do it manually. Anyone who wants to do it manually understands sort of, like, kind of the gist of what I'm doing. But I do just have to switch to using some scripting. Or it's just gonna take so long. So let's see. What are we doing here? So yeah, let me sort of say what we're doing. We want to begin with, for instance, here would be a perfectly good case. We want to drive our initial contour joint socket, just as we have for the ARM. We have our contour joint socket. I guess you can't really see that, but it is being driven by the input that is being driven by the shoulder guide. Same situation, right? But for the hip. So I will do something like this. I'm going to grab that one, and I'm going to say pa.pynode. I'm going to refer to inputs by name because I know there's only one thing called inputs, and also it's just convenient to not have to select it every time. Hip. That's the matrix input I want to be using here. And I'm going to say, oh wait, no, this is actually, I shouldn't do this yet. I should hook up the guides to the inputs. If I don't do that, we will definitely get some weirdness as everything probably collapses to 0, 0, 0. That is not actually what we want to have happen here. So, we would just fix it, but it'll be visually confusing. We might as well do this. So instead, I'm going to say this hip guide, grabbing the first item in the selection, dot world matrix, first item in the list, because in Maya, there's actually an array of world matrices that belong to a transform, because you can have instancing. At least I'm pretty sure that's why it is, but we always want the first one. And I'm not even, I don't even need to have a function for this. This is very simple. I'm going to plug it into and you can't see any actual change here, but it now has been plugged into hip. And if we want to just sort of see that is the case, let's just look at the inputs. Yep. Hip guide. We can even sort of look at it in here if we want to see like these things get created. But actually no, because the other nodes aren't even in there. I just find this in many cases much faster than trying to like manually hook up each thing. It's just, having to like lay them out in some way. It is a funny thing, and it probably has more to do with the fact that the node editor, like Maya's node graph, was never really intended. It wasn't built at the same time as the node editor, right? The node editor was a late addition. It's actually fairly recent in Maya's history. Actually, no, I'm just old. It actually isn't that recent in Maya's history. Anyway, the point is, when Maya's node graph was originally designed, it really looks to me like they didn't really think very much that users were going to be interacting with it a lot, right? It was like you were going to do stuff in the UI, and that was their internal representation of the scene, and the user wasn't supposed to have to really understand it. But actually the user totally does have to understand it if they're doing rigging, for sure. I mean, you probably don't if you're doing modeling, or you don't need to understand it very much. You certainly do if you're doing rigging. So, there aren't really great ways of visualizing it, and I often just find it easier to do with code. So, let's see. Next thing. We did the hip guide, knee guide. Ball guide. Toe overshoot guide. All right, there we go. Now we can hook up the rest of it. So in that case, I am actually going to look at this in the node editor so that you can sort of see what happens when I run this function. I'm going to put the inputs in there, and I'm going to put the contour joint socket in there, which will eventually, we'll call something other than contour joint socket 1, but I'm not going to worry about it right now. And now we're going to actually make use of some of the things that I wrote there. So import component utils as cutils. Dot what am I doing here? Drive with matrix. And the second argument to drive with matrix is going to be the node that we want to use as the target, which is going to be the selection. And the first item in drive with matrix is going to be actually the result of well, actually no, I don't need to use matrix in space because I don't need to do any space stuff here. It's actually going to be quite simple in this particular case, and I'm going to be simply using pa.pynode. It's a capital letter. I mean, here is the one thing about typing stuff. It's possible to type it wrong, right? There's that. Inputs dot hip. And that is the attribute that it expects to take in, right? I'm driving it with the result of the hip. All right. Now, so this particular case actually didn't really save us that much time because all it does is stick a decomposed matrix in there, right? Because we're taking the direct matrix output of the hip and we're just decomposing it and using it to drive the thing. So if I did that by hand, like, it wouldn't really be a big deal, right? You know, it wouldn't be worth writing a function for it. But that is not the only thing that's going on here. But as you can see, it is in fact controlling it. Now, here's something else that I can do. Now that I have done that, I need to drive a bunch of other stuff, right? So in that case, for instance, I need to drive this bone and joint. Let me just throw them in here, and throw the inputs in there too, so you can sort of see what's happening here. And I think I have a function in here. I think I do, that's specifically for driving contour bones. Indeed. Let's take a quick look at that. So as you may recall from an earlier stream, the way that we drive the contour bones and joints is a little different than just driving a single transform. Now, you could have cases where you're driving a single transform in ways that are much more complex than the simple relationship we just created, which is just like a single decomposed node, right? But it's one of the things that you do have to be careful of when you actually drive a contour bone is that you need to drive two different things. There's the actual length of the bone, and there's the next joint orient, which is what is essentially buffering the next joint. And one of the things that is quite nice, and I've talked about this, multiple times here, but it bears repeating. One of the things here is that it's quite nice is that contour bones have a length. They are a specific length, and that is a separate question from if they are stretched. One of the things that always irritates me about Maya joints is that they're just transforms. So they don't know anything about their, like, sort of the canonical state of their like bind state, if you want to put it. It doesn't actually have to be the bind state, but their sort of canonical state, their base pose, right? Rigs usually have such a thing. Maya joints don't know what that means, right? They kind of do. They know a little bit about it because they can have this joint orient thing. And it sort of is very frustrating because Maya joints have a joint orient, but that's all they have. And they don't know anything about how far away they're supposed to be in their base state from the previous bone in the chain, previous joint in the chain. Usually that's actually translate X, or I suppose translate Z or something else if you're using some other axis to point your stuff down, which is an abomination, but like sure, whatever. Like if that's what you're into. And so it's basically like they don't encode enough information. Like this sort of goes along with a bunch of the stuff that we're sort of we've talked about at various times and have had various sorts of rants about. But again, like it's all mixed in with other stuff, so it maybe bears repeating. Like Maya doesn't know what a rig is, right? Maya doesn't really have any inherent concept of what any of this stuff means. It only understands that there are nodes that do a few things and that they can be hooked up to each other in various ways. And that while that can have some advantages in terms of freedom, like you can sort of see why they wanted to set it up that way, and making something that's too rigid is also very, very bad, right? So I'm not saying like, well, we should have things that are extremely rigid in there, like a framework that's extremely rigid would also be bad. But the way that Maya has no sense of like a higher, like an organization to the graph. It has no sense of abstraction. It has no sense of what any entity is beyond a single node, right? And that's also not perfectly true. There are assets, but mostly people won't use them and they have various issues, is a big problem. Contour at least sort of chips away at that with the idea that the bones and joints kind of do know something about what they're supposed to be, right? Bones have a length and a stretch. So those two values are separable. You can plug in a different thing to the length and then also still stretch and still know what your canonical length is, right? Have a sense of like what is the bone actually for, and what data does it need to know what it's supposed to do. Hopefully that made sense. I mean, it probably sounded very vague, but and as a result, though, what we need to do is to break this up when we're plugging stuff into a bone. We need to plug the distance between these two things into the length, because that's the thing that we are essentially setting using from our inputs is the length of the bone, and then the orientation of the next joint. Well, that's next joint orient. That's more straightforward. Isai Calderon, again, I'm sorry if I mispronounce your name, says, I wish human IK API was more available to riggers within Maya. Need me from full body IK and with stretchy HIK joints in my life. So, there, I admit a certain amount of personal distaste for HIK. And I will grant that is to some degree a prejudice. Because, of course, my experience with HIK is all on the Maya side, where, so I understand it is not the same in Motion Builder, right? Like, it's actually a much more reasonable thing. Given what HIK does, I think it would actually be pretty difficult to make stretchy HIK. That said, it wouldn't surprise me in the least if the API, at least as expressed in Motion Builder, was a lot better, right? And had a lot more information. I mean, there, for instance, absolutely is a case where, HIK does actually know what a rig is, right? It has a sense of a structure of like what things mean in a way that sort of natural Maya rigging doesn't. I would say, and again, I am coming at this from a point of view of someone who has only experienced HIK in the Maya context, right? So take this with a grain of salt, right? I feel that it's too restrictive. Because while human IK certainly has an idea of what a rig is, it's an extremely specific idea. And it's an extremely specific idea that mostly doesn't do the things that I want it to do, right? But a more clean, overarching concept of a rig with a strong concept that doesn't necessarily imply specific behavior would be really, really ideal. I think that this is sort of what Epic is getting at, actually, with Control Rig and UE, where Control Rig has a concept of what a rig is, but it doesn't imply a lot about what your rig is allowed to do or how it's supposed to behave. Right? So in my view, that's sort of a good example of something that's kind of, it's sort of what, borrowing a phrase that you use a lot, Tagore, it's frameworky, right? Like, it has this idea of like, okay, this is what a rig is, and this is how other things can interact with a rig, and, it's got something a little bit rigid there, but then how the rig is allowed to behave and how you're allowed to organize the rig. And it has actual tools for abstraction for doing that, because it's basically just a blueprint. Like, that's pretty open to you and very malleable and very capable of performing, a wide range of fairly programmable actions, including the new procedural stuff, where it's like, oh, you just decide on what controls you even have programmatically. That's sort of like the good version of auto rigging as we currently understand it, right? I haven't used Control Rig enough to be able to understand all of its implications. So also be aware, like, I'm sure there's complications to their approach, but I do really like that idea, and I think you're kind of getting at a similar thing. I'm sort of inserting my like, oh, HIK, like, thing there, but in fact, I think the thing that you're getting at there about, is actually a very good thing, right? And I have heard that it's much, much better in Motion Builder.
Yeah, and I'll mention that we have been starting to take a look at Control Rig, and I think that we may, I think there's an excellent chance that we're going to try to do some stuff around Control Rig, although we can't talk too much about it at this point because it's still pretty provisional. But it's an interesting system from what we've seen so far.
Yes, like, it is something that and again, coming from someone who has done a very fairly small amount of actual production in it, a little bit actually, but not enough to have a real full picture of its capabilities. I'm pretty excited about it, right? Like, I'm pretty excited about its approach to things. But that is something that is still, in a sense, sort of on the way to being a generally usable tool, right? You can see how it's getting there. You can see how it's getting there actually remarkably quickly. But, there's absolutely still pieces to it that are missing, especially around deformation, especially around, communication between transforms and deformation, especially around, like, there's bits that are not there that will eventually need to be there. But what it does do, like, their basic concept of how rigs function and what a rig is, I'm super excited about. Anyway, so enough talking about stuff that we're not actually doing right now. Let's see. So what we were doing here is I was going to hook up that input to this contour bone. So in that case, actually I haven't run this function in a long time. I hope that there's not something about it that doesn't work. I guess we'll find out. Stop it, Windows. I was not trying to do that. Let's see. So it wants driver parent, driver, and target bone. I see what I did there. Again, I wrote this stuff over, like, years in different contexts and, like, kludged it together into something. I see what I kind of, like, had a different idea of how to name these things, but I kind of still have the same idea. I kind of still see what it's supposed to do. So basically what's going on here is it needs... So actually, to show what's going on here, I'm actually going to do something a little bit different real quick. I'm going to actually make a locator and just do a simple version of something that I'm then going to delete. Let's say that you had a locator and it was just parented to the contour joint socket. One second, I got to check something. Sorry, occasionally... Yeah, okay, there we go. Occasionally, because of my job, right, something comes up and it could theoretically be actually like a really urgent thing. So I always like to check, and I apologize for doing that in the middle of the stream, but it is sometimes important, right? Like, let's say, it doesn't even matter, I'm about to replace all that stuff. So here we've got a locator, and it's parented to the contour joint socket. If I did the same thing I did to the joint socket itself, like, let's sort of go back up to what I was doing there, and I did this whole, like, drive with matrix thing. If I did that and I took the knee thing and output it into this, I would, just using a decomposed matrix, I would get something that is completely in the wrong place. In fact, I'm not sure where the hell it is. Where did it put the thing? Seriously. All right, where? Oh, I see. I had the wrong thing selected. Okay. Well, it put it out in a weird place. And the reason for this is fairly clear, right? Which is that those matrices are not local. They are world matrices. What I passed from component to component are all world matrices. And again, I'm sort of restating some stuff that I've stated before, but sometimes it's important to state it in context, I'm hoping that these will be useful to people who aren't necessarily, like, already pretty experienced riggers. The locator, right, so these are world space, so of course if I take the world matrix, but it's parented to something else, that matrix is no longer the right thing. It has to be put into the space of the thing I'm actually attempting to do. Now, keeping in mind, none of this stuff is allowed to know anything about things outside the component. So the easy way to do that, the clear way to do that, actually, let me not delete that, let me just kill the decomposed matrix. The clear way to do that is to use other inputs to figure out what the matrix should actually be, the local matrix, right? So in that case, what I'm doing is, instead of passing it the input directly, I need to use matrix in space. Where, let me just take a look at what my code looks like there. Matrix in space. Here we go, with the matrix input and a space input. So in this case, my matrix input, here, let me just do this. I kind of wish I was using an actual text editor writing this stuff with autocomplete and stuff. The other thing I was showing was VS Code. I like VS Code. At least I like it a lot better than the MyScript editor. Blah, blah, blah. Not that this is a script editor, but I think you get what I mean. And now it is behind something. I gotta move it to the other monitor, sorry. Actually, you know what I'm going to do? This will make things easier. I'm always referring to the same inputs. So I'm going to say, but input is an actual name that gets used for stuff in Maya. So I'm just going to call it like inputs, right? You know, instead of constantly referring to it by its name and a pi node and all that stuff. So that's inputs.ni. Oh, right. I was pasting that in there. Inputs.ni. And then the other one is inputs.hip. Right? So here I'm saying the thing I want to plug in there is actually the ni in the hip space. So let's bring our node editor back up here. And I didn't have anything selected, so of course it did not. Wait. Oh, right. Also, I named this wrong. And I had the wrong thing selected, so give me a second. Where did I put that locator? There it is. No, it didn't like it. What are you talking? All right. Maybe it was cutils. And I did it. Yeah, okay. I did it the wrong place here. There we go. Yes, I did something kind of incorrect here. Remember how I said this was all kludged together? I don't remember why I did it this way in the first place, but it actually didn't work the way I thought it did. No, it's outputting matrix sum, which is actually a matrix thing. And this is a matrix input, so that probably should have worked. Where was it trying to get... And I'm using drive with matrix. That should have worked, right? You're plugging the output of matrix in space, which is a matrix attribute, right? That's the matrix input, into drive with matrix, which is going to decompose it and plug it in. Sure seems like it ought to have worked. Yeah, it got to the point of making the decompose and did not like it. Mult matrix has no attribute or method named translate. Oh, it switched the selection. Ah ha ha ha. Yes, this happens all the time. Well, so I will also say that the other thing is you can get very unfortunate stuff. So here's what happened, right? I have this thing where I'm passing in S1, which is the selection that I'm getting. Here's the problem. When you generate a node in Maya, but by any means, including scripting, it will change your selection. So, of course, it has no idea. It only gets to the point of actually doing that after it's already evaluated this and changed the selection on its own. So I'm just going to tell it what node to use for the moment. I mean, I don't know. There's other ways to get around this, but that's the simplest thing. For now, it's called locator 1. There we go. Here's what it did. It is now, and you saw me do something very similar in the finger manually. It is taking the hip world matrix, taking the knee world matrix, putting it in the space of the hip using this mult matrix node. How is it doing that without inverting the matrix? This is clearly wrong, isn't it? Yes, it is. It is clearly wrong. What the hell? 1 second. Wow, I don't know what I copied and pasted this from, but it was clearly wrong, and I don't know what I was thinking. This should be... Or do I already have, like, an invert matrix in here that inserts that? I don't, actually. Well, as usual, Watching someone actually rig stuff is embarrassing. I'm actually going to make one, though, because that's how I want to do this.
Yeah. Live coding has its perils, but...
It certainly does. But also, like I said, this is cobbled together from stuff that I did in different ways at different times, like, in different contexts. And clearly, I wasn't really thinking about how it went together when I should have been. Anyway, invert matrix... Right, I'm not going to do this. I'm going to do this. And this is the other thing about trying to turn this stuff into composable functions. Instead of like, I mean, you can see me, and when we get to this part, you know, I'll make that more clear here too. But you can see me doing that instead of writing it out longhand, as it were. Which, you know, isn't actually a bad idea all the time, especially when you're trying to figure something out. But when you're doing stuff where you want to be able to sort of bash stuff together like this, it's really nice to be able to be like, oh, here, this is gonna, I can chain these things together, you know, instead of to do whatever behavior I want it to do, instead of I have to write out line by line, I make this node, I hook this thing up, I do this, I do that, right? It just makes it much easier when you're doing this kind of ad hoc scripting, except, of course, for the part where I apparently left out an important point. So, I need to do matrix input. They're all named different things. Dot, is it matrix in? Maybe it is and maybe it isn't. I'm going to have to go find out. What does it take in? Thanks for not telling me, node editor. Input matrix is actually what it's called. And we'll assume it's actually camel case. Yeah, but this one's matrix in, right? Not input matrices or something else that would actually, you know, be consistent. We'll assume it's camel case because Maya things usually are, even though the attribute editor is lying to me. You can make the channel box stop lying to you, actually. I don't know if there's a way to make the attribute editor stop lying to you. There might be, actually, and I just don't know about it. But anyway, here's what we do then, and this is why I like this sort of thing instead of, you know, writing, like, a whole bunch of lines. And why I didn't do that, is that then we can just do, like this is an input, right? We're putting it into a matrix input. It's giving us a matrix output. So one of the things that's worth noting here is that these functions, they don't take in nodes, they take in attributes. So it doesn't actually matter that this one's called output matrix and the other one's called whatever, right? You know, it doesn't make any difference, right? Because we are specifically saying here is a matrix attribute. We don't care what it's called. It's just going to, and then before you can plug it into any other matrix attribute. Like so. This, I feel, is much nicer than, like, going through and doing it all out like that, you know? Assuming, of course, I didn't screw it up somehow, which, you know, let's find out. Code that is simple enough that you can reload it. Always nice when you can actually have it. Yeah, it's utils. Alright. So, let's try this again. Oh, we don't even need to select the thing, like... We can't even refer to it by selection the way we're doing it right now. That's more like it. So this inverse is actually pretty important because, you know, and again, I did this by hand in an earlier one, but I'll point it out here too. I am putting it in the space. I'm putting the knee in the space of the hip. And then I'm decomposing it, and then I'm putting it into the locator. But I didn't have to do it all manually. And even though I had to rewrite a thing, now every time I need to do this, I can do it in a second instead of manually doing stuff, which is horrific. It doesn't necessarily have to be in theory, but it often is in practice. So what this means is that our locator did indeed end up exactly where the knee is, even though it is parented to the, this contour joint socket, because it is getting its transformation from, well, ultimately from the hip guide, right? But, you know, from the hip input. So this is, I did this whole thing, even though we don't actually want this locator, we don't care about it. I did this whole thing so that it would make more sense. So that what's going on here with this other function would make more sense. because where do we have drive contour bone, driver in parent space. Oh, that's how I was doing it before. Well, that's fine. I was instead of getting the we wouldn't be able to use it, so I actually have to change. I actually have to change how this works, because again, I cobbled this together from like 10 different places. But matrix in space in this case was if you're giving it an actual node to get its actual inverse matrix from, you can just pass it in. But in our case, we don't want to be giving it nodes for our purposes here. We want to be giving it. We're going to call this. I'm actually going to change the order of the argument so it matches what's up there above. We want to call this matrix input and space input, just like we have above. And then target bone. We're going to plug matrix input in here and space input in here. But here's what we do to the space input. We do the exact thing we did before. Invert matrix. Oh, it's so nice to be using an actual text editor. And this should actually do the right thing. Probably. I guess we're about to find out. Oh, hey, I even did the correct absolute value thing here that I forgot to do when I did it by hand and caused us so much trouble when I was doing the invertible finger. So, next thing, you're going to grab this bone. I'm going to say, because I'm just going to say bone equals S1, because I don't feel like doing that whole thing where, I actually could implement something here where it resets the selection. That would make this easier. Maybe I'll do that later. But what I actually want to do is to say, yeah, we need to plug in. Yeah, we're not doing drive with matrix. We're doing drive contour bone. And we are plugging in directly. It already does its own matrix in space. Knee input, that's your input matrix. Hip input, that's your space. And we're not driving a locator with it. We're driving what I call that thing bone, right? Bone, like so. Did it work? It did not. Yeah, well, did I forget to reload? Yeah, I did forget to reload. Almost worked, but not quite, because this is obviously wrong. Let's see what it did. Sorry, I didn't really mean this to turn into a, oh wow, it has two inverse matrices. That's clearly incorrect. Right. Duh. Because, this is already matrix in space. I did not need to invert this matrix. All right, let's rewind that. Let's just delete all this stuff. It'll do the trick. There we go. Now, all that may have seemed, and so here's what this means, right? Here, it is actually properly driving the bone's length, as we've been doing with these components, so it all comes off the inputs. Now that we're doing that, we've written that. Here's the part where it actually gets better, because you might say, look, you could easily have done that all by hand in the time that it took you to debug that stuff, but now I can just do it and stop worrying about it, and it will always work. So in this case, we want the input being the knee and the ankle. And that's going to drive that bone, which we already told it was. That did not work properly, and why didn't it? You just see what it's doing there. Well, the length is clearly wrong. It's possible I put ankle something incorrect from ankle's actually outputting to the inputs incorrectly. Let's see. Yeah, it has a bunch of aim constraints. I don't care about those. Oh. Oh. It's not going out to the inputs at all. No wonder it's broken. Yeah, the knee guides are. The ankle is not. I must have forgotten it. There we go. Now it is. And now this works properly. There we go. That is what I expected to see. I tend to use the node editor more for visualizing things and just checking on them than actually making the connection. So, I mean, it's not like I never do that. Yep. This seems to be working. Everything seems oriented as it should be, and it is. There we go. This one we already got. All right, we now have the guides driving. Oh, actually, we don't. I mean, right, they're not driving this yet. But again, now we actually get to do this, and hopefully it does work this time. In the space of the ankle, we will apply that to the ball of the foot. No. Eventually one of these will actually work properly. Right, because I actually I see why that didn't work. I didn't tell it what the bone was. There we go. Yep, there we go. And finally, this last bone. Let me actually do it properly this time. This time, I promise you, it's not going to fail. Oh, what was this one? Toe overshoot. There we go. That one actually, I think, worked properly the first time. Yes, it did. See, it is possible. It can happen. Anyway, so what we have now is sort of the most rudimentary form of the componentized rig, right? It's the guides outputting their stuff to the inputs node, and then the inputs outputting all of their stuff to get this joint chain configured, and have the correct proportions and everything. Now, one thing that is... Now, actually, if this were, and indeed, just as the finger is a pure FK chain, if this were a pure FK chain, we'd be done. We made a component. Congratulations, right? Obviously it's not, and that's where it gets complicated. Which is that we need IK, but we don't just need the IK that the hand has. We need a reverse foot IK. And here's where being able to drive things in the space of other things off the inputs is going to be really invaluable. Because we do not know... Well, okay, we don't know what kinds of nodes we're going to need to put down, but we do know the general locations we'll need to put them down in, right? I mean, we're going to make up this reverse foot rig. I mean, I kind of know what it's going to need to be, because reverse foot rigs tend to be kind of similar. The nodes that we actually... We don't know we don't know what nodes exist. We do know where nodes will need to exist, though. And what this means is, regardless of what thing they're parented to, as long as their parent also is being defined by the inputs, we can always figure out their correct local space, like transformation, by looking at them in the space of some other input. Which is, again, one of the reasons why it's really important that these inputs are all in world space, and not already in some local space. Because this makes it really, really easy to figure out what anything needs to be relative to anything else. It'll, like the thing we're eventually going to do for the pull vector needs to know about 3 different things, right? We don't need to figure out where any of that stuff came from. We don't need to figure out what hierarchy that matrix may have been in. We can just use it and put it in whatever hierarchy, by doing that mult matrix that I was just showing you, at any, in a contextual way, like whatever we need it to be relative to something else, no matter what that thing is. In that sense, it is a little bit ephemeral, right? It has a certain similarity to the ephemeral system in that respect. Like, you figure out what something needs to be relative to something else when you need it to be that thing, and not and you don't make assumptions about what it should be before you need that information. One second. I've been talking for a while here. So, we have components, we have the inputs. Let's start putting down the basics of our foot rig. Or perhaps, it's 6:30. And these are supposed to go about an hour and a half. Now, I actually spent more time ranting than maybe I should have. But I think actually this is a good breaking off point, because there's going to be lots of stuff to do when we start building the actual IK and reverse foot rig. But actually, I could see this being done after another session, assuming I don't rant too much. And maybe if I do rant a lot, then it will be done the session after that. But, it is actually, although a lot more complicated than the finger, partly due to contour, not nearly as complicated as it could be. So before we officially, say this session is done, I do want to, I want to note one thing, because I need to get some of these rants out, right? We're not doing a foot roll. Like, we're definitely doing a reverse foot rig. Foot rolls are evil. I don't want to put any more evil into the world than already exists. And I can rant about that another time if you want. But, yeah, I mean, basically, I would like to throw it out to any of our viewers. If you guys have questions or anything really that you'd like to talk to us about, please do so. And, if not, that's fine too. But this is certainly a good time.
And while we're waiting to see if anybody does have any questions, I'll just reiterate something that we mentioned briefly at the beginning of the stream. Not a lot of viewers, though, at that point. So I thought I would mention it again, which is we have actually started implementing this, putting it into Contour. And we're going to start off just, releasing. We're going to start off with a simple release and add features as we go. So it's not going to be completely full-featured, but the first thing we're going to do is put a standard biped into Contour that'll allow you to just basically import a body plan, paint some weights, and get a biped. And then over time, we'll do things like add tails and quadrupeds. And I think the biped at least is coming probably pretty soon. We don't usually like to put firm dates on things because sometimes they take longer than we anticipated. But I'm kind of thinking, 6 weeks-ish. And I think that'll bring us to the Contour 1.1 release. But it could be longer than that. But I just thought I would mention that while we're kind of sitting here waiting.
Yep, and nothing has appeared, so that again, that's also fine. So yeah, that was we will be here next week. It turns out I will be able to be there next week. I wasn't sure because of holiday travel and stuff, but it turns out I will be able to. At the same time, Tuesdays at 5. Won't be here the week after that. Probably no shock to anyone. But we'll see how far we get then. Please tell all your friends they should show up to the Notional Pipe live streams where we rant a lot about rigging and animation related things. And please like and subscribe because that's what you do when you when you like something and want to subscribe to it. So I hope that we'll see you all then. Thank you so much for coming.
Yeah, thank you very much, Raf, as well. And thank you all for coming, and we'll talk to you next week. Bye-bye.